Today we're going to be looking at rational and irrational numbers. This is a picture that I took on my vacation this summer. It's called Devil's Tower and it is outside, it's in Utah. It was pretty cool. Firstly, since 7 squared is 49 and negative 7 squared is 49, negative 7 times negative 7 is 49. 7 and negative 7 are called the square roots of 49. So we're going to be talking a little bit about square roots in this unit. Example 1, we've got the square root of 64 is how you would read that. So you're going to think, what number times itself is 64? Well, the only number times itself that's 64 is 8. So the square root of 64 is 8. Example 2, we've got this negative square root of 100. Means what's the opposite of a number times itself that equals 100? So for that, let's see. The opposite, I'm going to go ahead and just bring that negative sign straight over. What number times itself is 100? Well, 10. So the answer to this would be negative 10. Your turn. Find the square root of 81 and the opposite of the square root of 25. Pause your video and try these two on your own. Make sure to put these on the right side of your notes. Did you get 9 and negative 5? If you did, draw a smiley face with some curly hair. If you did not, give yourself an X. Once you figure out where you made your mistake and you're able to correct it, put a circle around your X. When we're talking about perfect squares, and those last two are the problems that we've already talked about, have been examples of perfect squares. Perfect squares are numbers that have integer square roots. For example, these values here are perfect squares. The square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4, the square root of 25 is 5. And we could keep going infinitely with these perfect squares. Perfect squares are an example of a rational number. A rational number is any number that can be expressed as the division of two integers. These numbers include numbers that have repeating decimals, terminating or decimals that stop, integers, which are your positive and negative whole numbers, and fractions. For example, 0.3, and remember that line up above means that that number is repeating. So 0.3 repeating would be considered a rational number. 0.75, that's a decimal that terminates or stops. So that's a rational number. So repeating and terminating numbers, decimals, are rational. 2/7 is irrational. It's written as the division of two integers. 5, we could write that as the division of two integers. We could write that as 5 divided by 1. You could write it as 15 divided by 3. There's infinitely many ways to express 5. 4.5 is also an integer, is also a rational number. And lastly, the square root of 16 is rational because the square root of 16, what number times itself is 16? 4. So the square root of 16 is considered rational. Irrational numbers are the opposite of rational numbers. Irrational numbers are non-repeating and non-terminating decimals. These numbers are a lot, there's infinitely many of them, but there's not as many that are going to come to mind. The numbers that are irrational numbers include pi and the square root of anything that's not a perfect square. So for example, other than pi, we've got the square root of 5. If you were to find the square root of 5 on your calculator, it's going to be a decimal that goes on and on and on forever and ever and ever. So that would be a non-terminating, non-repeating decimal, or an irrational number. We could also say the square root of 6, the square root of 7, the square root of 8, not the square root of 4, because that's 2, and not the square root of 9, because that's 3. But all of these values are in between the square root of 4 and the square root of 9, so they would be considered irrational. Your turn. Pause your video for just a moment and list 3 rational and 3 irrational numbers that have not already been listed in this video. Since these are numbers you're coming up with on your own, I won't be able to come up with all of the possibilities, so we'll talk about these in class. Our last task for today is to graph rational and irrational numbers on the number line. The first thing you need to do is look at the sign. Anything with a negative sign is going to be to the left of 0. Anything with a positive sign is going to be to the right of 0. Let's start with 0.143. 0 is here. 0.1 would probably be there. 0.143 is just going to be a little bit more to the right. So I'm going to put a dot there, and then I'm going to go ahead and label that as 0.143. I'm going to hold off on the square root of 5 just for a minute. Negative 7/3. Well, negative 7/3, 3 goes into 7 2 times with 1 left over. So that's really the same as negative 2 1/3. So I'm going to go negative 1, negative 2. Negative 2 1/3 is going to be a third of the way between negative 2 and negative 3. So I'm going to put my dot there, and I'm going to write the original number. So I've got negative 7/3. I've got that one, I've got that one. Negative pi. Pi equals 3.14159, on and on and on and on and on. So negative pi is going to be negative 3.14, on and on and on and on. So that's going to be just a little to the left of negative 3. So that's my negative pi. I didn't mention this on the previous page, but pi is irrational because it never stops and it never repeats. So it keeps going and going forever and ever. There's a poster in my back of the room with a bunch of digits of pi, and that's not even close to getting to all of them. Negative 2.173461, that stops, so that's considered a terminating decimal or a rational number. Let's see, negative 2 1/3 in decimal form, that would be negative 2.3 repeating. So negative 2.173461 is going to be a little bit closer to 2. So it's going to be right about there. So I'm going to put negative 2.14, I'm sorry, 2.173461. So my only value that I have left is the square root of 5. Square root of 4 is 2. The other side, we've got the square root of 9, which is 3. So the square root of 5 is going to be somewhere between 2 and 3. It's really close. 5 is really close to 4. So it's going to be very close to 2. So I'm going to put it just a little bit to the right of 2. We'll label that the square root of 5. Your turn. Graph these 5 different numbers on the number line. Pause your video at this point and give it a try. Did you get your numbers graphed in this fashion? If you did, give yourself a shooting star. If you didn't, give yourself an X. Try and figure out where you went wrong with your particular number that you graphed incorrectly. If you figure out why it should go where it goes, put a circle around your X. If you did not figure out why it goes where it goes, put an X next to the value. So if you messed up on this one, for example, put an X next to your value so you'll know to ask about it tomorrow. Your homework for tonight. I want you to choose 3 rational and 3 irrational numbers that you've not already seen in this video. Graph them on a number line. Have a great day.